Okay, welcome to section 6.5. Section 6.5 is solving exponential equations. And so we're going to spend a little bit of time here talking about how to solve equations when you have x and an exponent. Okay, so let's just review what we've learned so far. Okay, we've learned a lot of things, but primarily with solving, what we've learned is that we know how to solve something like 2x plus 1 equals 7, right? That's like super easy algebra. You subtract 1, so you end up with 2x equals 6, and then you divide by 2, so you end up with x equals 3, okay? And then we spent a lot of this semester talking about how to solve something like that, right? And you had multiple methods. You could complete the square. You could use a quadratic formula. You could, I don't know, factor. Sure, why not? You could graph. So those are the two main ways that we've learned to solve equations. And so the goal then of this section and the last problem that we will do is we will learn how to solve something like 9 to the power x plus 1 equals 1/3 to the power 2x minus 3. Okay? So that's kind of where we're going. And you're like, whoa, I didn't even know that was a thing. And I'm like, yep, here we go. So let's just start out simple. All right, let's start out here with example 1. And in example 1, we need to solve 3 to the power of x is equal to 3 to the power of 2. Excuse me. So what that means is, well, we need to know what x value makes this equation true, and don't think too hard. Okay? If you have 3 to some power and it's equal to 3 to the power of 2, then that power must be 2, right? The 3's aren't going to change. 3's always going to be equal to 3. So then that means their exponents have to be equal. So it's x equals 2. Okay, so let's go a little bit further then. Let's do example 2 here. And on example 2, we're going to solve 2 to the power x plus 1 equals 2 to the power of 5. So again, we have a similar situation where we have 2 to some power equals 2 to the power of 5. So if 2 to some power equals 2 to the power of 5, then that power must be 5. And then we can solve. So you subtract 1 and x is equal to 4. Okay? And if you went back and plugged it in, it should make sense, right? If you plug in 4 right there, 2 to the 4 plus 1 is equal to 2 to the 5th. So that's good. Solving's always awesome because you can always plug in and check your work. Okay? Okay, let's go a little bit further here. Example 3. Okay? What if we wanted to solve something like 6 equals 6 to the power 2x minus 3? Okay? And you're like, well, I understand that it's exponential because there's an exponent out here, but this is an exponential. And my answer to you is, well, I get that. However, when you don't see an exponent, the exponent is 1, right? If I would have put a 1 there, I didn't change anything about my problem. You can't change an equation, but you can do things to both sides, right? Or you can rewrite it differently. So we can say that, well, 6 to the power of 1 is the same, and then you do have exponents that are equal. Okay? So if we add 3, we get 4 equals 2x. And then we divide, so we get that 2 is equal to x. Okay? Moral of the story is that when the bases are the same, so like the base here was 3, the base here was 2, the base here is 6. When the bases are the same, you set their exponents equal. Okay? Might want to write that down. I'm going to say it again. When the bases are the same, you set the exponents equal, and you only get full points if you have that written on your notes, by the way. I'm going to say that again. You only get full points on this assignment for those of you that decide not to watch the video with sound. When the bases are the same, you set their exponents equal. That's So I will know if you watch this with sound because you'll have those words written on the piece of paper. Okay, moving on with life. All right, example 4. Okay, let's look at a situation that looks like this. What if I said solve 2 to the power of x equals 1/2? Okay, now the the first thing you have to realize is there's only one exponent, okay? But then you also have to think about, well, now there's a fraction, okay? So I want to know 2 to what power would get us to 1/2. And here's what you have to understand about exponents, okay? There were a bunch of rules in 6.1 and 6.2 that I think a lot of you have forgotten, and one of them is regarding negative exponents, okay? So like, let's say I had 3 to the negative 1, okay? If we plugged that into the calculator, 3 to the negative 1, math, enter, enter, turns into 1/3. And if we had 4 to the negative 1, you would get 1/4. Okay, so what I hope you're noticing is that when you have a negative 1, you just turn it into a fraction and put that number on the bottom. Okay, that was an exponent rule. So here, the power that would make this 1/2 then would be negative 1. Okay? In that similar situation, around that same time, we also saw something that looked like this. Okay, so example 5. What if I want you to solve 2 to the power of x is equal to the square root of 2? Okay? And there was also about this same time that we talked about rational exponents. Okay, so like if I asked what is 9 to the 1/2, okay, so if I did 9 to the 1/2, that's 3. And if I did 16 to the 1/2, I'd get 4, okay? So raising something to the 1/2 is the same thing as square rooting, essentially. So when I'm looking at an example like this, the power that would give me the square root of 2 is 1/2, okay? Now these two examples are special cases that require knowledge from 6.1 to 6.2, and if you need those videos again, I can give them to you. Just let me know, okay? But those are examples. So you might see negative exponents and you might see fractions as exponents as well. Okay. All right, anywho's, moving on. Let's get out of that mess. Let's look at example 6. Okay. So, what if we did 25 to the power x plus 1 equals 5 to the power of x? Okay? Now remember, I said to you, and what you should have written down to get full points on these notes is when the bases are the same, you set their exponents equal. Well, the bases aren't the same here. And because the bases aren't the same, you cannot just set their exponents equal. Okay? But remember, one of the greatest things or the greatest pieces of advice that I can give you in math is if something doesn't look like it should, make it look like it should. Okay? And so if we know how to solve exponential equations with the same bases, then let's make this so that they have the same base. Okay? Now keep in mind you cannot change the actual value of anything, but you can rewrite it. Okay? So we have a 5 and we've got a 25, and we need to make them the same number. Okay? Now your gut instinct is probably telling you, well, square the 5. Okay, and here's why this is wrong. Okay, so here's a little aside, if you will. Here's why this is wrong. If we write 25 to the x plus 1 equals 5 squared to be 25 to the x, that is now a different problem. Do you see how this is different? That is not the same problem. You cannot do that because that creates a different problem. But what I want you to use that same logic and say, well, what if we did this? What if we wrote 25 as 5 squared to the x plus 1 and kept the other side the same? Now you haven't changed a thing. Everything still stays the same. 25 is just 5 squared instead. So you want to keep the smaller base. Write that on your notes for full points. Keep the smaller base. Change the bigger one. Keep the smaller base, change the bigger one. Okay? So we changed the bigger one to be 5 squared. Now, watch this. We've got these two exponents here, and exponent rules say, well, then we can multiply those. So we've got 5 to the 2x plus 2 equals, and then we still have 5 to the power of x. Okay? Now we have the same base, so we can just set the exponents equal, and then we can subtract 2x, so we get 2 equals negative x, so then we just flip those so that negative 2 is equal to the power, negative 2 to the x. Negative 2 equals x, excuse me. Okay, so two big major takeaways from this. Number one, you change the bigger one so that it has the same base. And then don't forget to distribute if you have a situation like this. Okay. Let's go back to our example 7 now, which was the one we talked about in the beginning, our goal, if you will. Okay. Example 7 says this. Okay, let's solve. And then the one we had was 9 to the x plus 1 equals 1/3 to the power 2x minus 3. Now this one's a little bit different. Okay, obviously they don't have the same bases. So we're going to take the same approach as what we just did on example of 6 of changing them. But this time we're going to have to change both, because there is no way to make a 9 into a 1/3. Not easily, at least. You can do it, it's just not easy. And there's not a really good way to make a 1/3 into a 9, okay, with the power. So we ask ourselves, well, self, is there a base they could both be? Is there a way we could write 9 as a base and 1/3 as that same base? And the answer is yes, you can choose 3. Okay, because you can write 3 to some power to be 9, and we just talked about how you can write 3 to some power to be 1/3. Okay, so 9 we could rewrite as 3 cubed to the power x plus 1, and then 1/3 is like 3 to the negative 1, and then 2x minus 3. All right, and now let's distribute here. Okay, so we've got 3 to the 3x plus 3 equals, and then we've got 3 to the negative 2x plus 3. Okay, and now the bases are the same, so we can just set their exponents equal, and then we add 2x and subtract 3, so 5x equals 0. And then x is equal to 0. Okay? That's as tough as this would get. All right? That's more test level. I would say example 6 is more quiz level. Okay? So we're going to talk a lot about these things on Friday. So come to class with questions. I bet you have several of them, and that's great. So come to class with those.